Good morning, everybody. My name is CG Priya. I am from Emertxe School of Engineering, Bangalore, studying BTech in Electronics and Communication Engineering. Currently, I am studying in fourth year, and I am looking forward to present what I have done today. So, I have been a student in this um, Emertxe institution where they have taught me numerous things, including C language, the types of C, the advanced C. They taught me microcontrollers, embedded systems, etc. Mainly, the aim of this internship was to make a project. So this is the project that has been created, that is called microwave oven. So before getting into this, the main part of the project, I would like to first give an overview of the whole internship. So the main objectives of today includes introduction, the C programming language, embedded C, the microcontroller that we used um, for this internship, that is PIC 16F877A, that comes under the family of PIC microcontrollers, the tools which we use to implement all of this, introduction to microcontrollers, embedded systems, communication protocols, and the internship project with the conclusion. So, we are going to start with the C programming language. So, C is a very, very powerful programming language. It is one of the most popular languages, as well as it is a general purpose language. Even though it is applied and used effectively in various specific domains, it was developed in the early 1970s by Dennis Ritchie at Bell Labs. It is a free formatted language, that is, it is not a strongly typed language. It is known for its efficiency and a close to hardware programming capabilities. It is efficient and portable. It is a procedural imperative programming languages. It has various library facilities. One of the most one of the biggest advantages of C is that it contains a library, lot of library. So yeah. So the main applications in C programming languages include system programming, embedded systems, compilers and interpreters, game development and database systems. So there are certain categories that comes under C, one of which is keywords. So keywords are the main component of C which is used in the programming language while coding. So there are different types of keywords. Those are data types, modifiers, qualifiers, loops, jumps, decision, storage class, derived, user defined, and others. So if I am to explain one of the types in keywords, I want to choose data types as it is the most commonly used keyword in any by any of the beginner level programmer. So data types is basically um, how you initialize a variable, array, string, pointer, let it be anything, how you initialize a program. So data types include char, int, float, double, etc. Char is character where you can use strings, int is integer for arithmetic like numbers, float is for decimal points, double is also for decimal points. Like if you take another example, that is loops. Loops are repetition. If you want to repeat the same code, you don't have to write it more than once. You can put it in a loop like for, while, or do, and it will work accordingly. Jump statements is when you want to jump through a heap of codes when those are not needed. So this is an anatomy of a simple C code. So as you can see, it's written my first C code, that is a file header that can be treated as a title. It is an unofficial title of the whole file. All the or the certain, it can be treated as a comment as well. So you can properly document each and every part of the code so that if you look at it later you will be able to understand. Hashtag include stdio.h means you are including the library of standard input and output of the hex file. Int main is what starts the whole program. So whatever you write inside the int main is the main program or the body of the program. Printf, scanf, those are the statements that I used. Printf is what prints the statement inside that printf into the console. Scanf takes in the value. Return 0 is a program termination. So concluding C, now we come to embedded C. That's the programming language that I have used in my project. So in embedded C is a computer only understanding language. It is a low level language. There are two types of embedded C language. Not necessarily two types. There is something called an assembly language, which is what stems the languages like C, Python, C++, Java, etc. So this embedded C, it is usually represented in the number in embedded C is usually represented in decimal, octal, hexadecimal or binary. As we all know, decimal is a type which ranges from 0 to 255, octal ranges from 000 to 0377, hexadecimal ranges from 0x00 to 0xff, binary is from 0 and 1, 2. So decimal is to the base of 10, octal is base of 8, hex is 16, binary is 2, etc. So binary, if we take it, it is computer can understand only two types of states, that is high and low. So those are binary digits. So we call it bits. So data, how we represent it? We can represent it through all 5 of the ways. That is bit. Bit, how can we represent? It is high or low, right? So we can represent it in any of them. Now if we take bytes, it is a unit of digital information. So it commonly consists of 8 bits. It is considered as the smallest addressable unit of memory in the computer. Now if we take word, it is the amount of data that a machine can fetch and process at one time. So word can be, if you take a word, it can be in the form of hexadecimal. So usually in assembly languages and all, they use it in terms of word, and they take it in terms of little Indian, big Indian, etc. Positive numbers, negative numbers. I am sure everybody is familiar with integers that are like whole numbers, which does not allow negative numbers are positive. And negative integers are represented with the 2's complement of the positive number. Now we go to basic data types. So the basic data types in embedded C includes integral and floating point. We all know, we learnt, I went through it last time for C, that is integral comes under data types which include int and char. Floating type it includes float and double. If you take data types, modifiers and qualifiers, it includes size, signedness, const and volatile. Size has short, long, long, long. Signedness has signed and unsigned. Now these are conditional constructs. So if you get into more of embedded C, we come across different operators. Those are arithmetical, logical, relational, assignment, bitwise, language, ternary, underflow and overflow. So arithmetic, if you take, arithmetic is basically multiplication, division, addition, subtraction. Logical is like not, and, or. Relational is greater than, less than. Assignment is float, how you assign certain characters. Then bitwise operators are to perform operation on bits. So it can be integral. Return type is integral value. Bitwise is bitwise and, bitwise or, that is to compare values. Same way left shift, right shift, everything exists in byte bitwise. Language mostly consists of size of to know. So we need to know the size of a number. So we can write it as size of num. So we'll know the size of the number. So ternary operations are more like if else operators which contain in one line itself. Overflow underflow is when it so there so what happens is there is a boundary, there is a limit for how less the number can go and how the maximum and minimum limit of a number. So if it goes under the limit, it is called underflow. Over the limit, overflow. So other functions of embedded C includes arrays, we know arrays, pointers, functions, strings, storage classes, and preprocessor. So this is what we have used in the project this time. This is called PIC16F877A. So this comes under PIC family. So it is a popular microcontroller manufactured by Microchip Technology. It is a part of the PIC, that is Peripheral Interface Controller family of microcontrollers. It is widely used in various embedded systems and electronic projects. The applications of PIC16F877A include home automation, robotics, security systems, traffic light control, etc. So the tools that we used in this internship is MPLab X IDE, where we coded all the PIC microcontroller basically embedded C. We coded the thing that we have to put in the microcontroller in MPLab X IDE. The compiler that we used in that is XC8. It is a cross compiler. And the code that we wrote, we saved it as a hex file and then opened it in this simulator called PicSimLab. It is a simulating tool mirroring the exact features and qualities of PIC microcontroller that we need, where we simulated using the code that we got. So microcontrollers. So what is a microcontroller? A microcontroller is an integrated circuit which is capable of being programmed to perform a specific task. The design which has normally a restrictions on its memory size, input output capabilities, peripheral functions, etc. So there are what is the difference between a processor and a microcontroller? So a processor is a chip, and a processor is a chip which can do several functions. A microcontroller has a microprocessor with additional features. That is what you call a microcontroller. So these are all separate components. A microprocessor is a bit more flexible, and it has a bit more design complexity, like it has CPU, ROM, RAM, timer, ports, etc. If you take a microcontroller, all components of a microcontrollers are in a single chip. So if you take a microprocessor, it had CPU, RAM, ROM, port, and timer, right? Here we'll have different other features as well. It is less flexible and it has less design complexity. So you can choose a microcontroller based on its performance, price, availability of tools, special capabilities, etc. Now we are going to talk about embedded systems. So I'm going to introduce embedded systems, which is the core part of the project. So any combination of hardware and software which is intended to do a specific task is called an embedded system. So examples of embedded system include, like, anything that we have in our daily lives is a part of it contains embedded system in it, basically, like a microwave, washing machine, TV, CCTV, fridge, anything like car, aeroplane, the mobile phone that we use, everything is has embedded system in it. So the categories of embedded system include standalone, real time, networked, and mobile. Real time Standalone is means that it is an independent embedded system. It does not need any extra or outer help from any of the other devices. Real time is an embedded system where it works real time, and it is very important to know what kind of a real time embedded system we are dealing with. There are two types of real time: hard real time and soft real time. So if you are taking hard, it will be like very complicated devices like nuclear weapons, etc. So we need those. So those are deadlines, my bad. So hard and soft deadlines. So yeah, so network soft include like our remote, where we can just the deadlines are not that serious. So the common design matrix that included in the embedded systems are time to prototype, power, performance, size, NRE. NRE is non-recurring engineering cost. That is one-time cost for making a microcontroller. Maintainability and flexibility, safety, unit cost. Unit cost is the whole cost. And, I mean production copies of it, which does not include NRE obviously. And time to market. That is time to market is basically after you release, how much time do you have to market it. So I also want to talk about some of the challenges and trends in embedded systems. So challenges include: how do you optimize the code, how do you test and debug the code, how do you make the input and output more efficient, etc. Trends that happens in development include processors, memory, operating system, programming language, and development tools. Now, communication protocols. So, communication protocols is basically consisting of I to C, that is the integrated circuits. So this inter-integrated circuits is synchronous, half duplex, it has multi-master slave features, etc. So I I square C, as we call it, includes bus features, protocol, bus speeds, etc. So bus features, what is it? So bus features is a two-line interface. It is software addressable. It has multi-master with CD. It is serial, 8-bit oriented, and bidirectional. It also has on-chip filtering. Now, if you take the protocol, it has a complete data transfer. So if you take an I2C, it has a data and a clock. It will have a microcontroller, temperature sensor, EEPROM, RTC, that is real time clock, etc. So signals have two wired interfaces, that is SDA and SCL, serial data analog and serial data clock. So wired and conditions and data validity, the transmissions, etc. So now we are going to start with the internship project that I have done. So the aim of the project is to basically program and execute a microwave oven using the PIC 16877A microcontroller. The tools that are used are three tools: MPLAB XID for the code, XC8 compiler to compile the code, and PixSimLab simulator to execute and show the demo of the code. So the board that has been used here is like the board that has been used is the PixSimLab from Pixim. This picture is taken from PixSimLab simulator. So the board that we have used is PicGenius, and from that we have taken PIC 16F877A. So this is kind of like a block diagram that I've made of the whole process without complicating it. So our main aim is to make a microwave oven. So when we on the Pixim lab, we will have powering on microwave oven. You will get four options. So the four options will be micro, grill, convection, start. So micro will basically set the time. That is, we have to set the time for the food to be made or whatever we keep inside. So when we set time, we keep it in terms of minutes and seconds. This hash is to enter whatever time we have made, and a star is to clear. So if we have clicked on enter keypad, the time will start. You can even um, start it if you click on 4, it will add 30 seconds to it. So that if we want it to be heated more, we can use it. Then we can pause it. We can, when we pause it and resume it, it will start exactly at the time. um, I'll be showing that in the demonstration, and if you want to stop it midway, we can do that as well. That is the first option, micro. The second option, that is grill. Grill goes to, um, it again sets time. It is of the same way itself. So grill, if you want to grill something, see, there are two kinds of, in a microwave oven you can either microwave it or grill it. So if you're grilling, it is almost the same process itself. Minutes and seconds, type it, enter, the time will go, and if you want to add 30 seconds to it, you can resume, pause, stop, any other. Convection is where you preheat before you properly heat it. So when you preheat it, you need to know the temperature of it, how much time, I mean how much degrees you want to heat it for. So here you can enter the temperature in degrees Celsius, and enter it or clear it as per our choice, convenience. So when we preheat it, after the preheating it, you can again enter the time, and it will start resuming the time as usual. The next is start. So you don't want to go through any of this. You don't want to customize any of your oven or oven settings. You just want to directly start. So when you directly start, you want to directly start heating the food in the oven. You can click on start, where it starts, and its default time is 30 seconds. You can add time by clicking on 4, which will add 30 seconds to it, and so on. You can pause, stop, etc. Now I'll be showing the project demo. So this is the code. Build it. It is successful. Now open this in the Pixel Lab. I have already opened it, so let it be this way itself. So if I am taking the first option, so power is equal to 900 watt, it's showing. If I am clicking it for 10 seconds, okay, 1 minute, and I click on enter, it starts, the time starts. Now if I want to pause it, I can click on 5. See, it is paused. If I want to resume it, sorry, it's not paused yet. Now it is paused. If I want to resume it, I can just click on 4. Now I want to stop it midway. So what can I do? I can click on 6. It is stopped. So that is what micro. Grill is of the same thing. It is a bit slow. Yeah. So again, click on how much ever time you need, enter. So it's only 2 seconds. Let's see what happens. Shows time up, and you get your options again. The same thing happens in micro as well. Now convection mein, when we click, we have to type in the temperature. So I need, for example, 22. Now enter. The preheating time starts. So if we wait for about 12 14 to 14 seconds, what happens is, it gets preheated, and the timer starts again, where the fan runs for a period of time, and then the uh, food inside the oven is heated. So let's wait for 5 more seconds. So now it is back to the options. Now fourth one. Again, it directly starts from 30th second. Now if I want to add 30 more seconds, I can click on 4. See, it directly adds 30 more seconds. How much ever I want, I can do. And now if I want to pause, I can pause it. If I want to resume it, I can resume. So now I am stopping it. It's a bit slow, that is why it's taking quite some time for it to get executed. Yeah, so that is about it. Thank you so much. um, Hope the project was uh, decent, and thank you all to all the teachers who have taught me, and yeah, thank you.